We saw RSVP. RSVP is a resource reservation protocol. Okay, so it stores the information between the source. Uh, so basically, soft state is a set of information at a router. Okay, that indicates about a flow, and you must understand that this ISA ISA is a flow-based service. ISA is a flow-based service. Because you know what is the meaning of a flow. So a flow is allowed to enter inside the internet with the requisite resources. So ISA and differentiated services have a difference, that ISA is a flow-based service. Okay. ISA is a flow-based service. What is a flow? A set of packets originating from the same source to be delivered at destination, and they seek similar kind of services during their transit in the network. And this is differentiated services. Another model, it is based on per packet. So you can see the difference, that this ISA services are administered on a flow label. Like flow means a set of packets, while the differentiated services are administered on a per packet basis, right? So as I was discussing about this RSVP, resource reservation protocol, this resource reservation protocol basically maintains the soft states about the flows in the routers. Okay, generally this information should be refreshed regularly. Okay, from the entity that requested the state. Okay, otherwise this gets expired after some time. Because suppose if a route expires for a particular source and a destination, then a new route information should be put, and the previous route information should expire, right? So like that. So what are the RSVP characteristics? It can be implemented for both unicast and multicast. It is simplex. That means only a unidirectional reservation is possible. Okay. So if the two end systems require data exchange, then two separate reservations are required in each direction. And the receiver initiated reservation, the reservation is made by the receiver, and it uses different reservation styles. There are around 12 different styles. It is given in 4 of them. Since time is less, I am not going into this, like the wild card and other things, right? 4 different styles. Sorry. So basically, this reservation style says about that how reservations for the same multicast group should be aggregated at the intermediate switches. So this basically makes use of a more makes use of the internet resources efficiently, right? So some routers which deploy RSVP, some routers which are not participating in RSVP, they offer a transparent operation, and it is valid for both IPv4 and IPv6. Now coming to differentiated services, see, as I told you in the previous class that ISA has been obsolete, okay, recently because ISA was limited. As you know that in case of ISA, these soft states are to be maintained at each intermediate, at each router, right, and to be refreshed regularly. Otherwise, this information will be lost. So suppose in an internet, right, which is very vast, okay, maintaining such information is a very difficult. Right? So the first issue that ISA faced was a scalability issue that it cannot be deployed and maintain these soft states. Okay, because whenever there will be a large volume of traffic, the amount of control signaling required to coordinate integrated quality of service will be difficult. Right? So we have not done any comparison. So that information, maintenance of that information is very difficult. Like in case of a very high volume of traffic, okay. So as the burden on the internet grows and the variety of application grows, so there is a immediate need to provide the differing level of quality of service, like more variety is required and scalability should be checked, right? So the differentiated service architecture is designed to provide a simple, easy to implement, low overhead tool to support range of network services differentiated on basis of performance, right? So some key characteristics of differentiated services are like the IP packets labeled for differing quality of service using existing IPv4 type of service field or IPv6 traffic class field. So if you remember in IPv4 header there was a TOS field or a type of service field, or in IPv6 there was a traffic class field, right? So IP packets labeled for differing quality of service, right, as I said, it is basically a per packet. DS is on per packet basis. Any specific size of that box is it related to the unit size? So how does it work? A service level agreement is established between the provider and the customer prior to the use of DS. So like what is a service level agreement? Like you are signing an agreement with a company that what kind of services you want from the company, right? So everything it will be written that I want this thing to be delivered from your end, and what will be delivered from what are my expectations from your end, and what kind of product I want, right? So that is all decided prior to the use of DS. Okay. So before the application enters, applies for the differentiated services, an agreement is signed between the DS service provider and the customer, right? And an application that these are the services will be there. So as long as this service level agreement is maintained, right? The user doesn't violate this service level agreement. Differentiated services assures that everything will be provided, right? The services will be provided in a proper way. But whenever there is a violation of this service level agreement, then it is moved back to a best effort service, right? So how does it work? As I said, in a per packet basis. So how DS works? DS uses this IPv6 traffic class field or a type of service field or IPv4 and put some code points into the packet itself. Okay. Earlier in ISA it was on a flow basis, but here it is on a packet basis. So once they put in the packet, okay, the information is being put in the packet, and that code, some code stating, we will see what kind of code. So one 6-bit code, okay, one 6-bit code is put, that is we say a DS octet, Okay, and 8 bits means 2 bits are reserved. So a 6 bit, so a DS octet is put into this IPv6 traffic class or type of service field, right? And the packets with the same DS octet will be treated in the same manner, like a flow, right? So if suppose 100 packets use the same DS octet, they all will be considered as a flow, right? So good scaling to larger network and loads. First of all, now there is no burden of maintaining the soft state at each router in a larger scenario. And moreover, even though traffic condition increases, like we get higher traffic load, then also there will be no issue of scaling, right? Implementing by queuing and forwarding based on DS octet, right? So, so based on the DS octet, that will state about what is to be done, what kind of queuing treatment is to be given, what kind of forwarding treatment should be given to the packet. Okay, no state info on packet flow stored. So, packet flow का कोई information store नहीं होता है, right? So DS services are defined within a DS domain. Okay. I will show you that. Yeah, this is called as a DS domain, right? This is called as a DS domain. So DS type differentiated services type of service is provided within a DS domain. So a DS domain is specified first, or in that domain only the DS differentiated services are provided. And what is a DS domain? Which is nothing but a contiguous portion of the internet over which a consistent set of DS policies are administered, right? So this is the portion of the internet, a contiguous portion of the internet over which the DS policies will be administered. So this portion is called as a DS domain, right? DS domain means DS policies are administered, and only in this particular domain only the DS services will be provided, right? So generally, a DS domain is under the control of one administrative entity. So, and the services provided across this DS domain are generally referred to as service level agreement, which is nothing but a service contract between a customer and the service provider. So that specifies the forwarding service that the customer should receive for various classes of packets, right? So here, so a customer may be a user organization or another DS domain, right? So a customer will receive a DS services that will specify that what kind of forwarding service it will receive, okay, based on the different classes of packets. And this customer can be an organization, user organization, or another DS domain. So it may generally happen that the packet will leave from another DS domain and will enter into this DS domain, right? So every DS domain, the set of policies may be different, right? So, and that otherwise, if there is no agreement, then it will behave like a normal internet and will provide the best effort service, right? So, as I told you that generally the administrator or the service provider assure that the customer gets the expected or at least the agreed quality of service. Agreed quality of service means what you have agreed in a service level agreement. So whatever is stated in the service level agreement, that quality should be provided to the customer as long as the service level agreement is maintained. It is not violated by the customer, right? So if a customer submits packet intended for destination within this DS domain, so a customer submits the packet, okay, for destination inside within this DS domain, then the DS domain is expected to provide the agreed service. So if the destination is beyond the customer's DS domain, मान लो ऐसा भी हो सकता है कि जो destination है वो इस DS domain में हो ही ना. So if it is not in this DS domain, then the DS domain will attempt to forward the packets through other domains, right? It is not like that only the intended destination will be available here. So in case if the intended destination is not a part of this DS domain, then the administrator will try, right? The service provider will try to forward the packet to the other DS domain in order to reach to the destination. So generally, while it does so, it approaches the other domains to provide the similar kind of treatment. Okay, what is listed in the SLA. So based on that, it does that. So what kind of service level agreement, right? What kind of service level agreement you mean, right? So DS services are defined within DS domain. So DS domain is nothing but a contiguous portion of internet over which the consistent set of DS policies are administered. And typically, it is under the control of one organization or one administrator and defined by service level agreement. So what kind of service level agreement we are talking about, right? So it is a service contract between a customer and the service provider, which enlists the detailed service performance, like what is the expected throughput, what is the drop probability, what is the latency, what is the jitter. Okay, so all those things are listed in that service level agreement, right? And once a customer submits the number of packets in the for to obtain the differing quality of service, the service provider tries to give them the best like the agreed quality of service, right, or what is listed in the SLA, right? So constraint on ingress and egress points indicating the scope of the service, right, like whether it is limited to in this domain, and if the intended destination is outside that, so how will it do that? Traffic profiles, right? So traffic profiling is done using the token bucket schemes. I yesterday told you that the token bucket scheme, that a packet is allowed to pass, like for queuing. So if this is basically done for traffic shaping. Okay, suppose a Basti, how will you characterize the traffic? Like suppose a source may be Basti, right? In that case, the flow is very excessive, right? That may cause congestion in the network. So how the traffic should be shaped? Okay, so that is what the traffic profiling is done using this token bucket scheme. Disposition of traffic in excess of profile, right? So if the excess of profile means if wherever the traffic profile exceeds, I told you there are two parameters. There is one traffic profile, okay, another is a reservation profile. So in case of a traffic profile, if any case, if it exceeds the traffic profile parameters, a service is deferred, right? The service is deferred and the best effort service is given. Okay. Now the what kind of service level agreement? जैसे आप कैसे बनाओगे? How will you make a service level agreement? So you can see that suppose if you have to prepare a framework document, how will you prepare? So I can say like a label A, traffic offered at label A, at service label A will be delivered with low latency. Okay, and traffic offered at service label B will be offered with low loss. Will be delivered with low loss. Label C, 90% of in-profile traffic delivered at service label C will experience no more than 50 millisecond delay. Okay, 95% of in-profile traffic delivered at service label D will be delivered, right? So you can see that label E, traffic offered at service label E will be allotted twice the bandwidth of label F traffic. Traffic with drop precedence X, higher probability of delivery than that of Y. So this is what you can see here, that that in a document, in a framework, the first two examples, okay, are qualitative, where you talk about that the traffic should be delivered with low latency and low loss, right? The next two statements, like for label C and label D, are quantitative, where you say that the in-profile traffic, the 90% of in-profile traffic at label C, service label C, uh, should experience less than 50 millisecond latency, or at service label D, it should be 95% of traffic, in profile traffic at service label D should be delivered. So these are all what quantitative, right? Here you can see that the 50 millisecond, 95%. Okay, so these are 90% of traffic, 95% of. So this is a quantitative. Okay, and this is what a kind of both qualitative and quantitative are mixed in this, like bandwidth offered at service label E should be twice of the bandwidth offered at service label F, right? Traffic with drop precedent X will be higher probability with delivery than that of Y. So these are a mix of the qualitative and quantitative. Now what is a DS code point? DS octet, it's a the packets are labeled for service handling by means of the DS octet, which is placed in the type of service field of a IPv4 and a traffic class field of IPv6, right? So the leftmost 6 bits from a DS code point and the right. So you can see that here in this diagram that the left 6 bits are used, okay, and the right 2 bits are unused. So the DS code point is the DS label used to classify packets for differentiated services. So it shows the DS field, like you can see here that the first 6 bits, this is what the default behavior, and there are different classes, okay, a class selector behavior. So from here you can get the different classes, and this is what in case of like the priority level also increases. So you can see that the higher level of precedence is indicated here. So this is once again divided like class, drop precedence, and unused. So these 6 bits. So class means class 4 is the best service, class 3, class 2, class 1, right? And drop precedence like 0, 1, 0, low, most important. So if the precedence is low, so that means the packet is very, very important. Medium, high drop precedence means the packet can be dropped. It is least important, right? And these 2 bits are reserved. So like that, there are different classes. 6 bits are there, so you can have 2 to the power 6 classes, right? So as compared to ISA, where only the 3 kind of services were offered, like the guaranteed, control load, and the best effort. Here we get 64 different kinds of services, right? As compared to ISA. So you can see that the code point, so there are 3 pools of code points. So this X is either 0 or 1 are reserved for assignment as standards. Okay, these are reserved for assignment as standards, and these are reserved for experimental or local use, and this form is used for experimental or local but may be allocated for standards in future. So within the first pool, several assignments are made. So the code point with all 6 zeros is the default packet class. Okay, the default class is the best effort forwarding behavior in existing routers. That is what the IP is known for. So such packets are forwarded in the order that they are received as soon as the link capacity becomes available. If other high priority packets in other DS classes are available for transmission, so these are given preference, okay, over best effort default package. So this is what it refers to, a best effort default service. So generally these packets will be allowed to pass, okay, only when the available whenever the link capacity will be available, right? If it is not available, or if a higher priority packet is there, so that will be given precedence over these. And the code points of this format, okay, these are reserved to provide backward compatibility with the IPv4 precedence service. Okay, and the precedence field is set to indicate the degree of urgency or priority. जो आपने देखा ना यहाँ precedence field, this is basically to indicate the degree of urgency or priority to be associated with the datagram. So if a router supports the precedence subfield, there are three approaches to responding. One is a so it can be a route selection. Okay, so particular route may be selected if the router has a smaller queue for that route, or if the next hop on that route supports the network precedence or priority. जैसे token ring network जो है वो if you remember in a token ring network that there was a token ring priority scheme, right? So similarly, the network service, if the network on the next hop supports precedence, then that service will be invoked. Queuing discipline, a router may use precedence to affect how queues are handled. I told you that there can be a fair queuing, there can be a FIFO queuing, or there can be a weighted fair queuing. So depending on that, if the router use precedence, okay, then that may affect this queuing discipline. So in a DS domain, if you see, right, in a DS domain, if you see here, so there are two types of routers in a DS domain. One is called as a boundary routers. These are called the boundary routers. Okay, and another one is called as the interior nodes. Okay, so these typically these interior nodes implement simple mechanisms for handling packets based on their DS code point value. So they serve the purpose of a classifier or queue management, the intermediate nodes. While these boundary routers have many functions, okay, their job is more complex. Okay, so this their job is like they act as a classifier. Like so, basically a traffic conditioner is implemented here at the boundary routers. What is the traffic conditioner? So this boundary nodes basically include the per hop behavior mechanism, but more sophisticated traffic conditioning mechanism. So what is the traffic conditioning mechanism? I will show you this. So this is implemented on a boundary router. Okay. As compared to the intermediate router simply perform the forwarding job. Okay, based on the takes the routing decision based on the class, right? So traffic conditioning function has 5 things: classifier, meter, marker, shaper, dropper. So when the packets are given to this boundary router, so first the packets are classified to different classes based on the type of DS code point. the packets will be classified into different classes. Okay, so and then they are given to the meter. Meter basically measures the submitted traffic for conformation to the profile. So if suppose मान लो जैसे सपोज कोई प्रोफाइल है, उसने बोला कि थ्रूपुट इतना होना चाहिए, 100 होना चाहिए. So if the meter will check whether the submitted packet are having the same throughput or not. So if they are so meter marks them, like if it is lower, so it marks them to the marker, remarks the packets with a different code point as needed. So suppose if now the throughput has to be increased, right? So it will mark them to get that kind of service. So if और उल्टा भी होता है, मान लो उसको ऑलरेडी थ्रूपुट ज्यादा है, तो उसको वो क्या करेगा कि उसको थ्रूपुट को कम करने के लिए उसको मार्क कर देगा लोअर सर्विस के लिए, एंड देन इट विल बी गिवन अ बेस्ट एफर्ट सर्विस थ्रू आउट द नेटवर्क, राइट? So shaper dropper, it delays the packets as necessary so that the packet stream in a given class doesn't exceed the traffic rate, right? Dropper packets when the rate of packets of a given class exceeds that specified in the profile. So this is basically, as I told you, until unless the packets submitted are in conference with the traffic profile, they won't be dropped, they won't be delayed. Okay, so and the meter is used to measure the submitted traffic in conference with the traffic profile as per the agreement. If it is if it is already getting higher than that, then they mark it at lower priority, right? So, so this is what so within the domain, interpretation of DS code point is uniform. Routers in domain are boundary nodes or interior nodes, and these traffic conditioning functions are implemented at the boundary node, right? So boundary node performs the exhibit this per hop behavior, right? So per hop behavior is a part of so per hop behavior, like as I told you, that as the packet moves on and it goes to the router, that the DS code point itself says that what kind of service it requires. So there are different per hop behaviors like expected forwarding. So as you know that at each router there will be some queue and the packets are buffered waiting to use a shared output link. So if it is the queuing behavior at each node that results in loss, delays and jitter. Thus, unless the internet is grossly oversized, to eliminate all queuing effects, care must be taken in handling traffic that is granted premium service. Okay, to assure that queuing effects do not result in loss, delay or jitter. There are per hop behavior. So expedite forwarding per hop behavior provides the first of the two capabilities, like so it supports the premium service, like as I showed, low loss, low delay, low jitter, assured bandwidth, end-to-end service through DS domain. So expedite forwarding behavior, per hop behavior, right? It appears to endpoints as point-to-point connection or lease line. So it is difficult in internet or packet switching network queues at each node or router. So we have to minimize, because whatever the delay, loss and jitter happens, that happens due to in managing the queues at the routers, right? So basically traffic scheduling, it is a part of traffic scheduling. So unless so a care is needed in handling premium service traffic, right? And there is an assured forwarding per hop behavior. So like you can so configuring nodes, no traffic aggregate has minimum departure rate, arrival rate less than the minimum departure rate. So first, network boundary conditions provide. Second, okay, border nodes control traffic aggregate. The limit characteristics. So basically, here we use a kind of a traffic profiling that is done using a token bucket scheme or a leaky bucket scheme. Right. So there are two types of forwarding: assured forwarding and this is a kind of a service superior to best effort. So there are three, like expedited, assured, and best effort, right? There are three types of services. You should remember there are three types of services: expedited forwarding, and another is assured forwarding, okay, and the third one is the best effort. Okay. So this finishes the second module, and we will be having a quiz tomorrow at 6 p.m. Okay. So don't miss the quiz. So if you have any genuine problem, you should inform me in advance, right? Otherwise, I won't conduct it again. Okay, there will be 20 questions of 0.5 marks each. PPT I have already uploaded. 25 minutes time will be given. 5 minutes, like 30 minutes total. Total 30 minutes will be given. Okay. Thank you.
Thank you, sir. Thank you, sir.